The aircraft carrier is a centerpiece of the U.S. Navy because of its ability to transport planes all over the world. The capacity to launch and land jets in such a compact space is the most important feature of aircraft carriers. The takeoffs and landings on this aircraft carrier, which is the largest in the world, require a lot of logistics to get it. Operational engineers have had to create basic yet effective technologies to help manage the process. The pilot takes off using the catapult device while landing, using the Fresnel lens and arresting wires. These systems have been in existence for decades. Even though technology will advance dramatically in the next 20 years, new systems will continue to be based on these original concepts. It's amazing how taking off and landing on an aircraft carrier works. Let's check it out. Launching from a catapult. Long runways are often required for an aircraft to gain enough speed to take off successfully. Engineers have created steam-powered catapults on the decks of aircraft carriers that can launch aircraft from 0 to 150 knots or 170 miles per hour in just 2 seconds. Even though the runway length on an aircraft carrier is only about 400 feet compared to the 2,300 feet required for normal aircraft to take off from a runway, the above-ground and below-ground operations are the two components that the takeoff system is based upon. Above ground. The crew uses a tow bar to attach the aircraft front wheel or nose gear to the catapult above deck. The tow bar is attached to the front of the nose gear to allow the catapult to draw the plane. A jet blast deflector is situated directly behind the aircraft to push the discharge up into the air, preventing hazardous jet discharge from entering undesirable regions. The pilot then accelerates the engine to full power, providing forward thrust that would normally propel a jet forward. Despite the thrust of the jet, a holdback bar is in place to prevent any movement at this moment. The extra force in the catapult will cause a holdback bar to disengage and the jet to move. Once the force in the catapult is combined with the thrust of the jet, this is because the holdback bar can only hold the force of a jet at maximum thrust, not the force of the catapult. Below ground steam is injected into the capsule below deck at extraordinarily high pressures. Steam goes up a lengthy tube that runs the length of the catapult. Whenever a valve is opened, the steam pressure is transferred to many pistons, which are held in position until the command to release them is delivered. A pulley system positioned in a crack extending the length of the runway connects the pistons to the catapult overhead. The pistons are freed and driven forward. Once the airplane is at full throttle and the steam builds pressure below deck, this forces a holdback device to disengage, which is solely designed to hold the force in the jet's drive to release and launch the jet into the air. The catapult must be swiftly stopped once it's completed its mission, the launch tubes, and is fitted with a water brake system. When the pistons strike the water brake, the pressure in the tube causes the pistons to rest swiftly. The pulley system then rapidly retracts the catapult, allowing the next aircraft to be hooked up for launch. The steam is pushed through the separate tubing by the retracted piston, so it can be reheated and reused for future launches. It takes about 30 to 50 seconds to complete the process. The procedure for landing, the most difficult task for a Navy pilot, is landing on an aircraft carrier for a good landing. The pilot must line up with the runway accurately, come in at the precise angle, and stop the plane in a short distance. This would be a terrifying endeavor for most people. But engineers have invented two mechanisms to assist them: the Fresnel lens and the arresting wires. The optical landing system with Fresnel lenses gives guidance for landing on an aircraft carrier correctly. The lens is placed on the side of the runway so that the pilots can view it during the landing process. A horizontal bar of green lights and a vertical bar of red lights on both sides of the meatball make up the optical landing system. The meatball is a centerpiece that is made up of 5 amber-colored lenses. Depending on the plane's angle regarding the meatball, certain lenses will light up one at a time. The center light appears to move up and down about the horizontal green bars on the side. The pilot strives to keep the center amber lens horizontal with the green bar throughout the landing procedure to land safely. If the pilot flies too low, the amber light will turn red, signaling that the plane is dangerously close to the aircraft carrier's back end. If the carrier is unable to accommodate the aircraft, the red lights around the green horizontal bars will flash, indicating that the jet must continue circling or locate another landing spot. Touching down. The most difficult part for pilots are the touchdown and the subsequent deceleration induced by the arresting wires. This landing maneuver requires not only amazing expertise, but also relies heavily on the ground crew ability to avoid any errors during the procedure. The pilot lowers the tail hook just before touchdown. The carrier's tail is a long metallic bar that hangs inches above the surface. The airplane is stopped when the hooked end of the tail snags one of the 4 arresting lines when it lands. Even though the wires are simple in design, there is a significant risk of something going wrong. Good pilots aim for the second or third cables rather than the first or the fourth, because these wires will prevent the pilot from colliding with the carrier's back while allowing for takeoff if they miss their goal. The pilot accelerates the aircraft to full speed as soon as the wheels touch the deck. This is to ensure that if the tail hook misses the arresting wires, the plane will still be able to take off promptly at the end of the runway before the plane arrives. A member of the arresting gear crew inputs the incoming jet's weight specs and double-checks the information. If the weight is entered too high, the plane may come to a premature stop, causing damage to the plane. Even worse, if the weight is entered too low, the plane won't be able to stop in time and will crash into the ocean, although the risk is always present. Significant training and practice make such disasters uncommon. If all goes according to plan and the arresting cable is activated, the cable will be drawn out through the deck, which will cause the jet to slow down. Both ends of the cable connect to a piston housed within a cylinder that runs parallel beneath the deck. Wires located above pulley systems power this mechanism. The volume of liquid that is placed inside the cylinder changes according to the total mass of the object being supported by them. The pistons travel through the tube when the wire is pushed, gradually forcing the fluid out of the cylinder. This occurs as the wire is pulled. The force exerted by the fluid causes the initial push on the pistons to be less intense, which in turn causes the arresting wires and the associated plane to move more slowly. After the airplane has come to a full stop and the engines have been turned off, the tail hook will be unhooked, and the arresting wires will be retracted and prepared for the arrival of the next aircraft. That will be all for today's video. Thanks for staying tuned.